Hey everyone, today I'm going to show you how to set up air-gapped AI inferencing for Db2 Genius Hub using vLLM and NVIDIA GPUs. For customers with strict security and compliance requirement, running AI completely within your data center is essential. This setup allows you to use all of Genius Hub's AI capabilities while keeping your data and processing completely local. Let's walk through the setup process using the official documentation, and then I'll show you a live demonstration of the same. Here is the official documentation page on setting up vLLM with Red Hat Container on NVIDIA. This shows you how to set up air-gapped AI for Genius Hub. Let me walk you through what we'll be covering today. First, let's talk about what you need before you start. You'll need a Red Hat account to pull the container images. You'll also need a GPU machine. We are using an NVIDIA H100 today, but Red Hat also supports AMD, Intel, and other GPU platforms. So if you are using a different GPU, the process is very similar. You just use the appropriate container image for your hardware. You'll also need Python 3, pip, and Podman installed on your system. Now let me walk you through the setup steps in detail so you understand what's involved. Step 1 is to log into your Red Hat account and pull the container image. Let me show you where to find the vLLM container. I'm on the Red Hat ecosystem catalog here, and if you search for vLLM, you'll find the Red Hat AI vLLM container images here. You can see there are different versions here for different GPU platforms. We are using the CUDA version for NVIDIA GPUs. This page has all the documentation and the pull commands you need. So the first thing you'll do is to log into the Red Hat container registry using your Red Hat credential. Then you'll pull this vLLM container image. The image is about 16 gigabytes, so it will take few minutes to download depending on your internet speed. The command is simply podman pull with the container image name. Step 2 is to set up a Hugging Face account, which is where the AI models are hosted. You'll install the Hugging Face CLI using pip. Then you'll need to generate an access token from your Hugging Face account and log in using that token. This gives you access to downloaded models from the Hugging Face Model Hub. Now let me show you the model we'll be using. I'm on Hugging Face here, and this is the IBM Granite 4H small model. This is an open source model from IBM. Once you're authenticated with Hugging Face, you'll download this model. This is a 32 billion parameter model, and the download is about 60 gigabytes, so this download will take some time. The command used is hfdownload IBM Granite model name, and it will cache the model locally in your home directory under the Hugging Face folder. Step 4 is to run the vLLM container. After the model is downloaded, you'll run the vLLM container with Podman. This is where you specify all your configuration, which GPUs to use, which model to load, what port to expose, and various performance optimization flags. We'll go through this command in detail during the live demo. Step 5 is to configure Genius Hub. Finally, once your vLLM server is running, you'll go into Genius Hub's AI configuration page and tell it to use your local vLLM server. You'll provide the URL for your vLLM server, the API key, and the model name. Now, to save time, I've already completed step 1 to 3, where I've pulled the container and downloaded the Granite model. Before we jump into the live demo, let me give you a quick overview of how this fits all together. You have your Genius Hub, where users interact with the AI, the vLLM server running on your GPU machine that runs the AI model, and Redis, which stores DB2 documentation locally. When a user asks a question, it goes to your local VLM server, which uses the Granite model to search the Redis knowledge base and generate a response. All of this happens entirely within your network with no external connectivity required. Now let's walk through the actual setup. Okay, so I'm logged into our GPU server here. Let me show you what we have set up. First, let me check the GPU. So you can see here we have an NVIDIA H100 with 96 gigabyte of memory. But again, as I mentioned, you could also use other NVIDIA GPUs depending on your model size requirement. Now let me verify that we have the Granite model downloaded. And here you can see the Granite 4H small model from IBM. That's the one we'll be using today. Alright, let's start the vLLM container now. First, I'm going to clean up any existing container that might be running. Let me just grab the command for the same. This just makes sure we have a clean slate. Now let's move on to run the vLLM. Let me show you the full command first and then I'll explain what each part does. This command has two main parts, container settings and vLLM settings. Let's start with the container setting part. The device parameter here gives the container access to all available NVIDIA GPUs on this machine. Then the port and the volume settings handle networking and model file access. Then we have the model parameter. This tells vLLM which model to load. We are currently using the Granite G8 small variant. Then we have the GPU memory utilization. This tells vLLM to use up to 95% of the available GPU memory. This is the API key for authentication. For this demo, I'm using no key. The tensor parallel size parameter is set to 1. This is the number of GPUs to split the model across. We have one GPU, so we are using 1. If you had multiple GPUs, you would increase this number for better performance. The other parameters are for performance optimization and container configuration. Alright, let's run this command now. So the container is starting up now. Behind the scene, Podman is creating the container with all the settings we specified, mounting the model files from our local cache and configuring GPU access. Once the container starts, vLLM will begin loading the 32 billion parameter Granite model into the GPU memory. This initial startup and model loading process typically takes about 30 to 40 seconds. In the meantime, let's watch the logs to see the model loading in real time. So the logs will show you vLLM initializing. You'll see detecting the GPU, loading the model configuration, and then starting to load the model weights into GPU memory. So the whole process takes about 30 to 40 seconds. So let's wait until the weights are loaded. Look, here you can see the loading weights took 14.5 seconds. So the actual weight loading was pretty fast. And now it's saying model loading took 60.0260 gigabytes of memory. So it's using about 60 gigabytes of our 96 gigabyte GPU memory. That's expected for this model size. And yeah, let's wait for a few more time for the application to come up. So now the vLLM is performing some startup optimization. It's compiling the model for better performance and setting up some memory caching. So this is a one-time process that happens during the startup. You'll get to see the progress bar showing the optimization steps completing. Yep, there we go. The application startup is complete and the server is now ready to accept the request. Now let's connect Genius Hub to our vLLM server. So I'm logged into the Genius Hub here and I'm going to navigate to the console, then to the AI configuration page. So here we have two options. One is IBM provided AI stack, and the other option is to bring your own AI stack. So we are going to select the bring your own AI stack since we are using our own vLLM server. Now I need to enter the connection details here. The base URL is the address of my vLLM server. In my case, the GPU server is that particular IP address and the vLLM is running on port 8000. So I've already entered the URL here. And for the API key, that's a no key that we had initially set up. And then we also have the model number. I have entered the IBM Granite 4H small model. The exact model identifier will be available in the drop-down. Now let's test the connection. Yep, you can see the connection is successful. So the Genius Hub is now configured to use our local vLLM server instead of any cloud service. Now let's actually test the AI to see it in action. I'm going to ask a question to the AI assistant here. You can select the database. Maybe just a simple question. What is the application heap size in DB2? So right now the AI is searching through the DB2 documentation stored in our local Redis knowledge base. It's using semantic search to find relevant information about the application heap size. So you can see it's giving me a detailed explanation about the application heap size from the DB2 documentation that's stored in our local Redis knowledge base. Let me also ask another question. Show me my current database configuration. Now the AI is determining this needs a live data. It's calling the DB2 API to fetch the current configuration parameter. So it might take few minutes. So yep, here is the actual configuration from your running database. The AI called the appropriate function and formatted the result. So you can see both capabilities are working. The AI searches documentation for general questions and also queries your actual database for some real-time information. All of this is happening locally within your network. Yeah, that's it. So to wrap up, we have set up a complete air-gapped AI stack for DB2 Genius Hub using vLLM with the IBM Granite 4 model on NVIDIA GPU. And all the detailed commands are also available in the official DB2 documentation. Thanks for watching.